Before I get started, I should tell you a little bit about myself. I'm a quant researcher here at Bloomberg, well, in New York City at Bloomberg. And I also am an adjunct faculty at Columbia University and NYU. And as an open source developer, I mostly work on Jupyter in the area of interactive widgets and on a lower level component called threadlets. Can you understand my Americanized French? It seems you can. So I think that pretty much everyone here knows about Jupyter, and which is a set of tools to improve the workflow of a scientist in scientific computing. And the tip of the iceberg in the Jupyter ecosystem is the Jupyter Notebook, which is a web-based interactive environment for computing. Although there is a quote by Richard Hamming saying that computing is more about insight than numbers. And as scientists, most of the time when you're using a report or console or a notebook, you are looking for insight and you're not building a complicated system based that would already be specified. You are trying to find answers to your questions. And this is where the notebook, and especially interactive widgets, are really useful. So the work that I'm presenting here is not just my work, it is the work of a lot of people. So every time I present a new component, I will put on the pictures of few of the people, some of the main people involved in each project. So the first project I want to talk about is the foundational layer for interactive widgets in the Jupyter Notebook. It's called Widgets. And if you want to install it right now, the latest version is available as a Conda package in the Conda Forge channel. So you can Conda install -c Conda Forge Widgets. So, sure, I can. Widgets. So what you need to do is Conda install -c Conda Forge Widgets. So everybody knows about the Jupyter Notebook, and it's a really nice environment to perform interactive computing, and also a nice replacement for the console where you can type a simple Python instruction and get the output printed below, like print 4 times 4. Last time I checked, it's still 16. And if you actually want to study or go further into the study of the square function, you can edit again the cell, hit print 7 times 7, and get the expected answer. If you want to be a little bit more efficient, you can write a function and call the function with different inputs. But as you see, every time I change the code, I get pretty much instantaneous response. And in that loop here, which is you typing the code in the Jupyter Notebook, hitting execute, getting a response from the kernel, and displaying the output, the bottleneck is you. And it's not the rest of the loop. And the point of widgets is to try to reduce that bottleneck here. So what you could do, for example, to reduce the time that you need to enter new input into this read eval print loop. So for example, what you can do is declare a slider. And a slider is, in this context, a Python object. And when you ask the IPython notebook, the Jupyter Notebook, to display the slider, it will provide you with a small interactive GUI component inline in the notebook that is the visual representation of that slider. So you can ask for the current value of the slider from your Python code, or modify the value. Well, here the minimum was 5, so it's being floored by 5, but you can modify it from Python, read it from Python. And now what I'm doing is linking a float text widget with a slider and displaying the output of the link between the slider and the text in the text area. Now, if I want, again, to explore the square function, rather than basically linking the values, I can add a transformation callback to the link object. And this time, what I'm going to see is the result of the square function. which is actually really accelerating that part, I mean, the left-hand side of the read eval print loop here. So there is another way to do the same thing, which is so we can also display another view of the same widget. So there is another way to do the same thing, which is to use the interact API. So interact is a function of IPyWidgets that uses the introspection features of the Python programming language to try to extract information about the function that you pass to it and build automatically a GUI to help you explore that function. So here, if I type interact f, where f would be the square function, right away it knows from the default value of the x argument that I provide that it should use a slider, since it is a number, and I will see the output of the square function over that range. Or I can use a slightly more, I would say, a complicated abbreviation for that slider, which is a tuple, defining the mean and the max value, and this time I have a more like a wider range. Or instead of using abbreviation, I can completely specify the widget that I should use for interacting with the x parameter. So in this case, I just ask for x to be an int slider with a mean being equal to 0, a max being 500, and with a step of 2. And there you go. So interact actually allows you to use the introspection features with more complicated functions. So in that case, I have a function that takes a string and number, a Boolean, and a tuple. So each one of these actually would be abbreviations for a type of widgets that should be used to interact with that parameter. So what I'm getting here is a automatically generated GUI where I can change the title of the chart. Instead of revenue, it's going to be profit. Modify one of the input parameters of the displayed function, or change the color of the line. So what's really happening here is that each one of these widgets that I've been displaying here inline is actually a synchronized object. So it is an object on the Python side and also has a counterpart model object on the JavaScript side. And every time I ask the notebook to display it inline, I'll get a new view of that widget displayed inline in the notebook or in a different layout. So every time there is a change of a model attribute on the Python side, it gets reflected on the JavaScript side, and the views will change their appearance accordingly. Every time I move the slider value on the JavaScript side, this event will trigger a model change in the JavaScript model, and which will be reflected and synchronized with the Python. So besides the slider and the few drop-down and other text area widgets that you've seen, the core IPython widgets library has a bunch of other components such as image, HTML, range sliders, label, etc. So, but more importantly, it's not only a small set of widgets, it is also a framework upon which you can build to make your own interactive widgets based on third-party or custom JavaScript libraries to display more complicated things inline in the notebook. So now I'm going to move on and show you Bqplot. And Bqplot is actually a lightweight plotting library that is built upon IPyWidgets that was developed by a quant team at Bloomberg. And so I provided some of the pictures of the authors here. It's Apache licensed. And what Bqplot provides is high-level plotting procedures with relevant defaults for the common chart types, such as histogram, line chart, heat map, etc., or bars. And also lower-level descriptions of data visualizations meant for complex interactive visualization, dashboards, and applications that would involve user interactions where you could use charts in the same way you use sliders as an input widget for other computation. So if you want to try Bqplot right now, it's also available as a Conda package and Conda Forge. So what you can do is Conda install -c Conda Forge Bqplot, and everything should work.
Is it going for Python 3 as well, or just Python 2?
Python 3 as well, yeah. This notebook is Python 2, but yeah, it's Python 3. So here's a quick, simple example where I import Bqplot, generated some data, and I simply call plot with a linspace for x and some other values for y and options for the axis, and you get what you should expect from any regular plotting library, which is an inline plot in the Jupyter notebook. But unlike the current state of Matplotlib, this plot is fully interactive on the JavaScript side. So for example, you can zoom in and zoom out, or download the image as a PNG, or reset the current zoom and pan and zoom attributes to the earlier values. So for now, there's nothing really original here. It's just a regular plotting library that has a bunch of high-level routines to create scatter plots, line charts, histograms, maps, and many others. But it's pretty standard. But more interestingly, actually, these are just higher-level functions that tap into a lower-level API that you can use to build more complicated visualizations. What actually happens here is that every single item on this chart is an independent widget that is an object that is synchronized between the backend and the frontend. So the scatter here, the axis, the color bar are independent widgets. So for example, here I can build a visualization by just assembling my visualization using these objects. So the core idea of Bqplot is that we are following a recommendation for plotting libraries called the Grammar of Graphics that is by Wilkinson, that is a set of recommendations about the architecture of how plotting should be done. And one of the main, I would say, core object in the Grammar of Graphics is the notion of scale. A scale is actually a mapping between a data and a visual quantity. It could be pixels, colors, size of a marker in a scatter plot. And the data could be numbers, categorical data. So as you build your visualization, you're going to create these mappings between your data types and the visual attributes. So what I'm doing in this example here is I'm creating one ordinal scale and two linear scales and a few axes being visual representations of scales. And finally, the marks, which are the items or glyphs that I put on the plot. So I create a few scales and a few marks. And finally, my figure is just a collection of axes, marks, and some top-level options for my figure, such as where should I display the legend. And there you go. Which makes it really interesting here is that I can dynamically change attributes of these objects and see the entire figure reflect those changes. For example, in that case, I can just change the data for the X data, the Y data for this line chart, and see the figure update every time I change the data. Or what you can also do is, yeah, same here for a scatter plot that updates every time I change the X and Y. So the same holds for the attributes of scale, axis, legends, any sort of label that you may have in the chart. So here, for example, I changed the minimum value of the X scale to 4 so that it's not computed from the data anymore, but it's actually pinned to 4. If I set it back to none, what I'm getting is the original chart that was where the ranges were computed based on the data.
Just spatial.
Pardon?
Can you do latitude, longitude on a map?
Yes, you can. Yeah, we have scales for geographical projections too. Two-dimensional scales, actually. So, moreover, Bqplot is not just a standalone library. It's very easy to bind it with other widgets of the core widgets library. So you can wire Bqplot widgets with other Jupyter widgets. So in this example, for example, I created a scatter plot and a slider, and moving the slider is going to allow me to change the rotation attribute of the markers live, and I don't really have to know any JavaScript to do this type of to do this type of things. So you can also use Bqplot figures as input widgets. So for example, you can make selections in a data set by just creating a selector on the chart. So this one selector here is actually interesting. It's an interval selector where the center of the interval corresponds to the horizontal position of the mouse, and the width of the interval is actually linked to the height of the to the vertical position of the mouse pointer in the chart. So it's actually faster to change the interval that is selected with such an interval selector than with like a regular brush selector, because where you would have to click multiple times to move the right-hand side or the left-hand side, so that you can easily storm through the data and perform an analysis on a specific subset without having to click multiple times. And of course, the selected attributes of the line is an attribute that is synchronized with the Python that you can react to with callbacks, etc. Or you can also draw on charts. And in this, I removed the selector and used the hand drawer interaction, and now I can actually draw and change the data of my figures. So if I have any sort of computation that requires that takes some function as an input, you can easily just draw the function and see what would be the outcome of your computation for that function. It's very easy to do. Same thing, if you want to tamper with data, you can easily take a point in the scatter plot, move it around, and see study what would be the impact. Here, for example, you see that the mean horizontal line is actually changing as I move the points. So that.
Will this be reflected back in your data set as you change that specific point?
Yeah, everything is synchronized with the Python side. And rather than computing the mean, it can be some more complicated analysis like PCA and all. So you can very easily test the sensitivity to a given point by just moving the point, which is.
The point as you move them, are the coordinates reflected in the data set? And can you extract the
Yeah.
points?
It's also reactive. You can have a callback that is on the Python side that is called. So all of this here, for example, here I made a very simple one where I am computing the mean on update line. So I should zoom in. I'm just saying that the value m.value is the mean. Lines.y is np.mean of scatter.y. It's an horizontal line. I don't know where the person who has the questions. Yeah.
Values, can you print us the values now, the new value of the new x and y value of the dot?
Yeah, you can. It's always synchronized. Every time you move, and every mouse move you get. I mean, you can actually parameterize that. You can decide to actually only get the event when you release the mouse, if there is too much computation done every time you move it. So it's very easy actually to. So the goal here is again to shorten that loop of interaction that you have with the computation, in that you don't need to change the parameters anymore manually. You can just do it graphically in the notebook. And so Bqplot is really meant to remain lightweight and to be more of an interaction type of library than a full-fledged plotting library that would do everything you want. And a replacement for Matplotlib, for example, see them more as input widgets than than the library that you want to use if you want to display 200,000 points in the page. It's not really the right tool for this. It's the right tool if you want to build this sort of interactive dashboard and applications where you can move points and see other dancing lines around reflecting those changes. So actually, we had some people who had never written any Python code or JavaScript in the past and could build as the first program, amazing dashboards where you have this sort of interactions. So it's actually fairly easy to use. Now, I wanted to talk about another package called Py3JS, which was studied by Jason Grout, who is now also at Bloomberg, and a couple of students of his, and I'm now also contributing to it. And Py3JS is another custom widget library that is a Jupyter widget wrapper around Three.js. And if you have never heard of Three.js, Three.js is a 3D scene description library for the browser. So let me give you a quick example here. So in this example, I'm plotting a Corlay here, and I have a point that is a picker on my surface. Whenever I double click, I would add a new point on the original surface. I can rotate, zoom, it's pretty fluid. And the way I describe this from the Python side is truly by describing the entire scene from the camera position, where the lights come from, what are the objects in the scene, and I get this sort of output as a interactive widgets. And again, every one of these items can be synchronized with the Python side and the result of computation. So this one example here was just a surface plot. You can also change the height dynamically, and you will see this reflected in the widget. So quick example here. So in this example, I had to make a concession, which was to write some JavaScript inline for the object that I'm going to display. And for example, here I'm just displaying some parametric surface, which I can rotate and zoom in. So Py3JS is a custom widgets library built upon IPyWidgets, and therefore is very easily interoperable with IPyWidgets. So you can link attributes of the Py3JS objects with regular sliders and other core widgets of the IPyWidgets library. So in this example, for example, I linked some attributes of the camera position with 3 sliders. And I have also a more complex parametric shape that is parameterized with 3 attributes, x, y, z, that I can change dynamically and observe the result live in my 3D shape that I'm exploring. So to respond to your earlier question, actually, on the right-hand side, I am changing the camera position every time there is a mouse move. And in this case, I'm only computing things when I release the slider. And the third, so if you want to install Py3JS before I move on, you can easily do this. Again, the latest version is available in Conda Forge. So you can do conda install-c, conda forge, Py3JS, and you'll get this version, and this notebook should run flawlessly. Now, Leaflet. Leaflet is the third custom widgets library that we released last week. It is a wrapper around the well-known Leaflet JavaScript library for mapping. It was originally authored by Brian Granger, and I sort of revived it some time ago to make it work with the new widget infrastructure. And so it makes it really easy to create interactive maps in the notebook. So in this example, I'm just setting the coordinates that I want to see, and I have a simple map inline. But you can also draw on it, add items dynamically from the Python side, and let me take this example where I take some data that is in the GeoJSON format that I'm just adding to the map dynamically from the Python side. So yeah, Leaflet is a really popular and powerful JavaScript library that has been used in many areas and has lots of contributors. And by just enabling people to create wrapper widgets on the top of IPyWidgets, you can bring the power of all the JavaScript ecosystem into the Jupyter notebook. And you really don't have to know much to do this. For example, there is a couple of weeks ago, I and a couple of other quants from Bloomberg participated in a hackathon in San Francisco, and we built a nice application using interactive widgets that I wanted to show here, where we actually have a combination of Bqplot and a choropleth heat map. And whenever you hover your mouse on a zip code in San Francisco, you would see a number of features of that neighborhood and scores displayed on the right-hand side, and which are computed dynamically by your Python code. And it's a really non-trivial application to make if you want to make it outside of the Jupyter notebook. And here, you don't really have to know any JavaScript to build this. So I have a couple of minutes more. So I wanted to talk a bit more about GIS. So you can also use libraries such as GDAL to interpret some GIS data. And here I downloaded some terrain elevation data from the Grand Canyon. And the Grand Canyon, which is available freely online and displayed in Py3.js. So unfortunately here, I didn't really adjust the camera position in advance. And it doesn't really look like the Grand Canyon. And if I want to adjust the camera position, what I could do is change it dynamically from the Python code and have a better perspective on the Grand Canyon elevation data. Although if I modify it again from the Python side, it's quite a slow process. So what we want to do is, again, accelerate that loop here between where the bottleneck is you typing the code in the cell. So sliders are nice, but they only bring you so far in that you can only modify one value at a time, so which is rather painful still. So it happens that the browser has an API for game controllers. So as part of the core IPyWidgets library, we actually integrated this support and brought it to the Jupyter notebook. So what you can do is declare a controller. So pad is equal to IPyWidgets.controller and display the controller widget. And what I'm being asked to do is to connect a gamepad and press any button, so which I'm going to do here. I brought my Xbox 360 controller with me. I plug it, press a button, and here I have an inline view of my gamepad. And as I'm moving the axes and buttons, I see the states inline in the notebook, right? And this is part of the core IPyWidgets library. It's not a custom library. It's really core to IPyWidgets. I can interact with those values from the Python code and read them, or react to their changes dynamically with Python callbacks. So what I did here is that I decided to bind the values of the axis to the camera position. And what I get is a 20-line flight simulator for the Jupyter notebook, so which I find is pretty cool. I don't think we can do anything shorter than that. Since I have a couple of more minutes, I wanted to talk a bit about the future, which is a very close future. It's almost the present. So the future of Jupyter is, so one of the things that will happen in the future of Jupyter, which is very bright, is Jupyter Lab, where instead of having a single page where you mostly have a notebook, we want to enhance the experience to that of a full-fledged desktop application, where you could have a text editor, console in the spirit of the Qt console, a notebook, file explorer, all that in a single page, instead of having new tabs open for you in your browser every time you open a notebook, and with a also like a more, I would say, flexible layout manager to handle panes and different parts of plugins of the application. So what about widgets? So we recently made a major release of widgets. And one of the main changes there is that we completely separated the JavaScript side of the interactive Python widgets into a library called Jupyter.js widgets that is a stabilization of the JavaScript API that should facilitate the work of kernel authors to implement support for other languages. So for interactive Jupyter widgets in R, Julia, Haskell. And so the next items that we have that we are working on for the few next weeks are the integration into Jupyter Lab and the deployment as standalone apps of interactive widgets. And so a couple of days ago, I also started working on a cookie cutter template for people who want to author new custom widget libraries by wrapping existing JavaScript libraries, which is available on GitHub, so under the Jupyter org, which is Jupyter widget example. Yeah. By the way, if you really like any of those visualizations, for example, I should restart the kernel here. What you can do now, which is one of the new features of the API, is that you can decide to embed interactive widgets, and you get a copy-pastable snippet of code that you can embed into any HTML page, and it will support custom widget libraries like Bqplot, IPyLeaflet, Py3.js. And if you follow our template for custom widget libraries, like the cookie cutter I was talking about earlier, then you will have all of this for free. So now you can easily build an application in the Jupyter Notebook, and once you like it, you deploy, and you have a standalone app running in the web browser. So yeah, that's it.
Thank you. Are there any questions? We now have microphones.
Thank you for the presentation. Very good. I wanted to ask, what are your thoughts on Bokeh, and are you thinking of merging your efforts, or why?
Yeah, we were discussing this just yesterday with the main author of Bokeh. I think there are areas where we could sort of converge. In that currently Bokeh uses a different way of being displayed inline in the notebook, and it could rely on the widget infrastructure for this. Another area of convergence could be...
You have the Bokeh server also, which could be helpful.
Yeah, so the Bokeh server is sort of, yeah, unrelated to Jupyter, I would say. And there is also, on Bokeh properties and threadlets are two ways of implementing the same thing, and maybe we could try to make them either make them more compatible or transparent for the user to use one or the other, and make them work together. So this is another area where we could work together. Yeah.
Go ahead.
Hi, great presentation.
Thank you.
When you moved it around with the Xbox, can you also drag it with the mouse as well, interactively?
Which box?
When you use the Xbox controller to move around the map, can you also drag it with the mouse as well?
Yeah, you could have also a mouse controller for the camera, and yeah.
Okay.
You could do both.
A great presentation. Again, a question regarding Bokeh and also Plotly. I mean, as a not so frequent user of graphics, I'm slightly confused that there is now another way or another library available. So which one would you recommend for which applications, and what's the difference, and do we have to really learn all three of them?
So I would say that, so there's Matplotlib, there's Bokeh, there's Plotly, there is that. About Plotly, I don't know much about it, except that it exists. So I can't really tell you much about it. It's GPL, this is my understanding. So if you want to use in a corporate context, it might be an issue. Between Bokeh, I would say that Bokeh is a much more large-scale project than Bqplot. Bqplot is really meant to be a lightweight custom widget library, and that lives in that world of custom widgets such as Py3.js, IPyLeaflet, and Bokeh is its own framework. It has also interactive widgets, and yeah, so yeah, there is. there is duplication there, but...
And matplotlib with Plotly, I mean...
So, yeah, matplotlib is a different beast in that a lot of the rendering logic, I mean, most of it, or all of it, is done in the backend. So if you want to have any sort of interaction in the context of a web application, if there is any latency with the backend, I mean, it's not going to work very well. So I would say that matplotlib is still the best tool if you want to have publication quality charts for your paper, but is not meant for dashboarding, web application building, or anything like this. Yeah.
Great presentation once again.
Thank you.
My question is about IPython widgets. So widgets, IPython widgets have evolved from IPython, Jupyter. Now it's a separate repo. They have a number of bugs, so it's been quite painful to keep up with them. So do you know if they're now in a sort of stable state? And another kind of follow-up question. So what you've shown, like the Jupyter lab is awesome. I mean, because that's what I think a lot of people want to be able to publish, like on the web, the notebook. So what's the roadmap for that project as well?
So for the widgets first, they were sort of an experimental thing for a long time, I would say, in the legacy notebook, in the current notebook. So the notebook has, and Jupyter in general, has gone through what we call the big split, which is to separate this massive monolithic project into multiple and more modular projects that could evolve independently. And lately, IPyWidgets has gone through the same thing. Now there is a Python side that is independent of the JavaScript library, which is, for the first time, sort of, I would say, stabilized in that we have a proper NPM package that will follow SameVer for the versioning, and so we will document a breakage of the API. So it should be more stable and easier to follow changes there in IPyWidgets. Jupyter Lab is a complete revamp of the front end of Jupyter. So if you have custom extensions for the notebook, you will have to work to do some work to make it work with Jupyter Lab. Although the widgets themselves, and especially the current branch and master, are meant to work in both the old notebook and Jupyter Lab. So, and soon you will we'll be able to do things such as have other workflows where you have a console, like a Qt console kind of input area, and a single output area will display all your widgets, a bit like Shiny for R. So yeah. So widgets is an area that should have compatibility, where we should have compatibility between the old notebook and the new notebook.
Yeah, so you will be using a lot of customer data with Jupyter. So how do you manage security? Also manage to set up Jupyter with multiple users? It's more of a DevOps question. If you have.
I didn't quite hear the second part of the question.
How you manage to set up Jupyter with multiple users, integrating with Active Directory, etc. Especially for a company like Bloomberg, security is a big thing. So it's more of a DevOps question. So
yeah, I'm probably not the right person to answer that, but I could say that the main feature of Jupyter is arbitrary code execution. So it's a feature. So if you want to have multiple users, you probably need to have some sort of isolation by VMs or Docker instances, and so which is pretty much the area of another project in the Jupyter org, which is called Jupyter Hub, which has utilities to do that. So widgets, especially custom widgets, are arbitrary code execution in the front end. If you allow custom widgets, you could have a whitelist of a load widgets. And yeah, this is another. We could take this offline and discuss it after. Yeah.
I just had a question about how closely coupled are the widgets to Jupyter? So if I wanted to run them off of my favorite IDE, which and I didn't want to put it in a Jupyter format, would that be?
So
run the same?
If your IDE can connect to a kernel, especially with the new Jupyter Lab thing, that we are building, you will be able to interact with that kernel and have them displayed elsewhere so that you, like in a browser window or something like this. And we have been working hard to decouple it from the notebook. And that feature that I was showing in the end, where you can just embed widgets and put it into any web page, is part of this, in that it doesn't really depend on the notebook JavaScript anymore.
Okay, thanks a lot.
New comment set up, please.
I have a question about the Jupyter Lab. Do you have a time scale for when that's likely to be available, at least as a beta that people can play around with?
No.
Okay, thank you.